Hello, I am Mitesh Pradhan from LabVIEW and Multisim. In this video, we will discuss about NI voltage input module. Suppose you want to acquire the data in terms of voltage, or suppose you have a sensor who generates data in terms of voltage, or suppose you have a system who is generating the data in the form of voltage and you want to continuously acquire and measure, and after the measurement you want to analysis and you want to store, so you can use NI voltage input module. Using NI voltage input module you can read any sensor data if and only if the sensor is giving output in terms of voltage. Suppose you have a experimental setup and you are acquiring the data, you are reading that value using the digital multimeter, so you can use the voltage input module and you can easily acquire analysis and store the data. Acquire the data means you can read the data, you can display the data on your computer, you can analysis in the form of graph and in the form of numerical value, and after that you can store. So if I will search NI voltage input module in Google, so I will get C series voltage input module, NI National Instruments. So today we will discuss about this C series voltage input module first. In the second lecture we will discuss about the PXI based voltage input module. So how this C series voltage input module look like? So for that, click on the image. Now you can see these are C series voltage input module. You can see here these are the connection pin. You can mount this voltage input module into the chassis, CDAQ chassis, and here you can connect your sensor. You can see the different kind of the connectors, sensor connections are available. Now you can see these are the screw terminal, these are also a screw terminal, these are the BNC kind of terminal. If you will see, look at here, this is the chassis. Now you can see this one is the chassis, and in this chassis, okay, this voltage input module are inserted. The modules look like this. These are the chassis, NI-DAQ, CDAQ chassis, and these are the modules. Okay, so let's see. You will get C series voltage input module. Okay, C series voltage input module. So now let's see how we can know which module is perfect for us or which module we can select or we can use. So there are large number of C series module are available, voltage input module are available. So first important things, the most important thing is, and the first important thing is, what is the voltage range? How much your sensor is generating? How much your sensor is generating? So now you can see here the voltage range. Suppose my sensor is generating voltage between plus minus 10 volt range. So I have large number of options. So now you can click here plus minus 10 volt. So now you can see 99% sensors generate the voltage in between plus minus 10 volt. Okay, if your sensor is generating voltage between plus minus 10 volt, so you have large number of options. Large number of options you have. Okay, suppose your sensor is generating value between plus minus 5 volt, only plus minus 5 volt. So you have this option, NI9205. NI9205 is really very good. Using this NI9205, you can measure data from any kind of the sensors. Why? Because it's provide plus minus 10 volt range, plus minus 5 volt range, 1 volt range, 200 millivolt. Suppose you are using a biomedical sensor and the sensor data is 1 millivolt, sensor's output range is 1 millivolt, so also you can use. And at the same time you can use 32 sensors. If your sensors are single-ended, so 32 sensors you can use, and if your sensors are differential mode, so 16 sensor you can use. Suppose you are using a EMG signal, you want to take the EMG signal and your system generating the 2 millivolt sensor generating, so you can easily use NI-9205. Okay, NI-9205, NI-9206 has same, NI-9206 has same 32 volt, 32 channel, 16 differential input, 32 single ended, same kind of capability. Okay, only the important things between NI-9206 and 05 is, you can see here, it is 60 volt earth grounded isolations. 60 volt earth ground isolation. Okay, so three kind of option are available here: 60 volt, 250 volt, and 600 volt. So it's 600 volt. Okay, voltage DC, earth ground isolation, only the difference. Now, whenever you will select any voltage input modules, so always keep it no. We don't need for the academic uses. You want to use the platform inside your lab, so click it no. Now we have these two options, NI-9205 and NI-9206. Suppose you want to measure data only 60 volt. You want to measure data in between 60 volt. So now you can see here you have, okay, you can use 9221, 9221, 9221. Okay, so you have only 2 to 3 option, 9221 and 9228, yes, and 9229. You have one option 9221. So let's see, let's try to discuss. So in 9221 you will get 8 single ended, means if your sensor is single ended, so you can connect 8 single ended. In 9228 you can connect 8 differential, and 9229 you can connect 4 differential. Now you can say, sir, okay, let's go ahead. Voltage or 60 volt range is fixed for all, and in between 9221 and 9228, 9221 can connect 8 different single ended, and it can connect 8 differential, and it can connect 4 differential. Now look at here, maximum sampling rate. So maximum sampling rate is 800 kilosample, 9221. So maximum sampling rate is 8221 for this. The maximum sampling rate is 800 kilosample per second for this 9221. So if I will open the calculator and so the maximum sampling rate is 800, and we have the 8 channel, 800 kilo. So let's go for kilo, divide by 8, so you will get 100 kilo sample. So each and every channel will get 100 kilo sample. But here you can see for the 9228 it has 1 kilo sample per second per channel. Okay, 1 kilo sample per second per channel, and 1 kilo sample per second per channel, and the bit, okay, the bit is 24 bit. Here you can see 50 kilo sample per second per channel, means every channel can read 1 kilo sample. Here every channel can read 50 kilo sample, and the resolution point is 24. Here it is just 2 times better than this. Now you can see here BNC, screw and spring. Spring and screw terminal don't have much difference, but if your sensor output is BNC type, If your sensor output is just like BNC type, so always go with the BNC based voltage input module. Now you can measure 400. You can measure the 400 volt RMS 3 channel. 50 kilo sample per second means 3 channel you will get, and you can measure the 50 kilo samples means per channel 50 kilo sample multiplied by 3, 1500 kilo sample. Yes, 150 kilo sample per second per channel, and the resolution is 24 bit. Clear? So now if you have only this voltage input module, so that is not useful. You need CDAQ chassis also. You need this kind of the CDAQ chassis. So here I can show you CDAQ 9171. This 9171 is one slot CDAQ chassis. In this one slot CDAQ chassis, you can insert one module. Okay, you can insert one module. Suppose, look at here. Not like this, like look at here. Suppose your sensor has BNC terminal and you want to measure only 4 channel, or you want to measure only 32 channel. So you can take a 9171 chassis and you can connect any on this. Suppose you want to measure the 400, so you can take this one and this module. Now if I want to measure the plus minus 10 volt only, if I want to measure the plus minus 10 volt and my data acquisition rate, I require high data acquisition. My data acquisition rate is very high. So now we can take 1 mega sample per second per channel. NI-9223 will give you the 4 channel option, and each channel will give you the 1 mega sample, and with the 16-bit resolutions. That means you can easily measure 1 milli. Okay, you can easily measure the yes 1 millivolt. Okay, 100 microvolt also you can measure, 10 microvolt also you can measure, and user resolution speed will be very good, and due to this sampling rate you can pick data very accurately and very easily. Your time difference between 2 points will be 1 by 1 megasecond. Okay, so 1 by 1 megasecond. So it is all about the voltage input module, and all this voltage input module support CDAQ and CRIO. Okay, you can control all this voltage input module with the LabVIEW, NI-DAQmx. Okay, LabVIEW, NI-DAQmx, Python, ANSI C and MATLAB. So thank you for watching this.